students. In this video, we are going to study about the technologies in the embedded system. There are three technologies: processor technology, IC technology, and the design technology. So we will study about all these three technologies of the embedded system in this video. So let us start with our topic. So let us first understand that what is a technology. Technology means the way or the manner in which a task is being accomplished. Okay, so for accomplish this task, we can use different methods, we can use different technologies, we can use different process methods and knowledge. Okay, so technology means the way in which the task is being accomplished. So whenever any task is being done, then we will use some method or process to do that task. Okay. Now, if we are using technical methods and technical knowledge or process to do that task or accomplish this task, then that is called the technology. Now, in the embedded system, there are three key technologies called the processor technology, the design technology, and the IC technology. So there are three key technologies in embedded systems. IC technology and the design technology. Now, as we know that in the embedded systems, they are what? The hardware and a software part. Okay, and embedded systems are those systems in which we can say that the software is embedded in the hardware. Okay, something is embedded in another thing. Okay, so here in embedded system we are having the hardware part also and the software part also. Now in the hardware part, the main or the basic part of the embedded system is the processor, because processor is the part which is performing all the processing or all the operations in the embedded system. Okay, so processor is called the main part or the heart of the embedded system. So the technology which is used to develop the processor or to choose that which processor is being used in the embedded system, that is called the processor technology. Also, the embedded systems, they are present in the form of ICs, okay, like integrated circuits. So what technologies or what methods are used to develop the ICs for the embedded system, that comes under the IC technology. Next, now whenever we are, because we know that the embedded systems, they are being used to perform some specific task. Okay, so for what task means, like if we are using the embedded system for a particular application, so according to that application we have to design the embedded system. So in the design technology, the different methods which are used to manufacture the embedded systems, that comes in the design technology category. So here we will study these three technologies in detail. First, we will start with the processor technology. Now, as I have already said that the processor is the main or the basic or heart of the embedded system. The function of the processor is to do all the types of processing and operations and controlling those operations, like the embedded systems if they are used for performing some calculations. So all the mathematical calculations, all the processing is being done by the processor. So these are all the functions of the processor. Now there can be different types of processors in the embedded system, and we know that the embedded system, they are used to perform some specific task. Okay, so for a specific application only we can use the embedded system. So this processor is also chosen according to the application of the embedded system. So we can say that processor technology, if we define this, then under the processor technology comes the architecture of the computation engine. Computation engine is what? The processor, because processor is doing all the calculations, all the complex computations and mathematical calculations are being done by the processor. So computation engine will be the processor. So the architecture of the computation engine used to implement a system's desired functionality. Because we want to develop the embedded system for some particular application, so we want that this embedded system should perform some particular function. So according to the desired functionality, we are choosing the architecture of the computation engine or the processor. So the selection of the processor according to the function performed or application performed by the embedded system, that comes under the processor technology. So if we talk about the processor, then there are some cases in which if we say that processor, it doesn't mean that processor is always have to be programmable. There are non-programmable processors also. By the term programmable means that we can do the programming, we can write the programs using the instructions, okay? And these programs are written into the memory of the embedded systems, and according to the program, the embedded system is going to perform some specific function. Okay, like if we want that a mathematical calculation like addition is to be performed, so we will write the program for that addition and then store that program in the memory of the embedded system, and then that system is going to perform that particular function. So embedded systems, the processors present in them, they can be programmable or they can be non-programmable. Now the processors, they can be of three types: general purpose processors, single purpose processor, and application specific processors. Okay, so there are three types of processors: general purpose, single purpose, and application specific. By these terms also you can understand the meaning that general purpose processors means that they can be used for any type of application. Okay, Single purpose means that for one particular application only they are used. An application specific processor means those processor which are used for that particular or that specific application only. Okay, so we will study these processors in detail. So by the classification of these processors, we can say that the processor, they vary in their customization. Customization means that in their design, that what are the components included in them, how they are going to work. Okay, so they vary in their customization for the problem at hand. Problem means that for the application for which the embedded system is to be used, the task which the embedded system has to perform, for that task, according to that, we are going to select or choose the processor. Okay, so the processor vary in their customization for the problem at hand. Okay, so according to the desired functionality, we are going to choose the processors. Now let us start with the first, general purpose. So general purpose processors, they are used in a variety of applications. They can be used, they are programmable processors, and one of the most common example of general purpose processor is the microprocessor. Example is microprocessor. So we know that the microprocessors, they can also be used for a variety of application. Okay, so whatever application, for what application we want to use, we will store the program of that application into the memory of these processor, and then we can use them. Okay, so at the time of manufacturing of these general purpose processor, no program is being stored. After the decision that for what function we are using the processor, according to that we will store the program in its memory. Okay, so it is at the time of manufacturing, it is having a generalized memory. Okay, if we see its structure, then it will have now in the processor. We know that there are two types of memory called program memory and data memory. Program memory, it stores the program, and data memory, it stores the data. Now from the program memory, the instruction register that is going to take the instruction, those instructions are given to the control logic and state register. These state register, they are connected with the program counter. Okay, so as to fetch the next instruction written in the program. So program is being executed by this controller. Now when this controller is executing the program, then it will need some data. So this data will be provided from the data memory. Okay, then on this data, the arithmetic and logical operations will be performed. Now these operations can be of any type, because we are developing the processor for the generalized application. Okay, at the time of manufacturing, we don't know that for what application this processor will be used or embedded system will be used. So we will use here a generalized ALU, arithmetic and logical unit, which can perform any type of operations. Now after that, the data is being processed and then the results will be stored. So these general purpose processors, the difference here is that they will be having a general ALU present in them, then program memory is there, data memory is there. So for whatever application we are using, we will store the program for that, and then the program or the embedded system can be used for any applications. So they are used in a variety of applications. Example is microprocessor. They will contain a general ALU unit in them. Now, what are the benefits of these general purpose processor? Okay, benefits, or we can say advantages. So first benefit is that they are having low time to market and NRE cost. NRE is the non-recursive expenditure. Okay, so that is also less in the general purpose processors, and also they require very less time for the to come in the market. Okay, like for their manufacturing and then for their testing and then coming into the market and selling, that is a very less time will be required, and also non-recursive expenditure cost is also less in it. Okay, these are the design metrics of the embedded system. Okay, whenever we develop any embedded system, we see that whether that embedded system is following those standards of manufacturing or not. Okay, then also they are having very high flexibility. High flexibility because we are using them for any type of application. Okay, so they are flexible. Okay, also these are the benefits. Now comes the drawbacks. If we see their drawbacks, then they are having very high unit cost. Means the components which are used for them, the per unit cost of the components is very high. Also, their performance is very low. So these are the features of the general purpose processors. Okay, we have seen its example, the microprocessors. Okay, now next type of processor is the single purpose processor. Now these processors, they are designed to execute only a single program. Okay, means for that particular application or for that particular one type of application, we can use these processor. So they are designed to execute exactly one program. So if we see the architecture of the single purpose processor, it will also consist of a controller. So in their architecture, you can see that there is no program memory present here, because the program is being stored already at the time of manufacturing, because they are developed for a single program only. They are going to execute only one program. So at the time of designing of these processors, the program is already being stored. So no option is there for the user that it can store any program. No program memory is present, only data memory is there. So data will be provided, and on that data the program will be executed. So the feature of this single purpose processor is that there is no program memory, and it will contain the components which are needed to execute that single program. Okay, so a limited number of components will be present. But in the general purpose processor, because they are to be used for different or variety of applications, so different components are present, number of components present in them is also very large. But here, because it has to execute only a single program, so components needed to execute that program only, they will be present, and no program memory is present in them. Now these single purpose processors, they also have some benefits and drawbacks. Benefits are that they are very fast as compared to the general purpose processor. Also their power consumption is very low, so low power is required because the number of components has reduced. Now drawback, no flexibility is present because they are used for single application only, so no flexibility as in the case of general purpose processors. Also they require very high time to market because they are to be used for that application, so their testing and manufacturing will require time. Also they will have high NRE cost. So the benefits of the general purpose processor, they becomes the drawbacks of the single purpose processor. Okay. Now next type of processors are the application specific processor. These processors are being developed for the particular application, for a specific application. Okay. Now, what's the difference between single purpose and application specific processor? In single purpose processors, they are being developed in very small quantity, and also they are doing only one particular function. But in application specific processor, there is a group of application, and for that group of application, we are developing the processor. Let's take an example. Like the example of single purpose processor is the digital clock. Okay, and this digital clock is being developed by a student. Okay, so that student is going to develop only one single digital clock, and that clock is doing the function of providing the time. Okay, means it is a time displaying unit, and it is going to show us the time, and only one single unit is being manufactured by a student. Okay, now application specific processor, its example is the microwave oven and the washing machine. Now these washing machines, they are developed by the industries. Okay, and they are developed in large quantities, and the particular application is that washing machine is used to wash the clothes, microwave oven, it is used in the cooking purpose. So application specific processor, for a particular group of application we are using them, and single purpose processors, they are doing only one particular function. Okay, so application specific processors are the processors optimized for a particular class of applications having common characteristics. Okay, now if we see the architecture of these application specific processor, again they will contain the controller. Now in these application specific processors, you can see that controller is there, control logic, state register, instruction register, and the program counter is there, program memory is present, and in that program memory, the program for that particular application is being stored. So here we will write the assembly code for that program and we will store in it in the memory. Now in the data path, because here the ALU has to perform the operations which are being specialized for that application only. So here the ALU is the custom ALU. Custom means which is customized for that particular application only. It will do the operations related to that applications. Okay. So in the general purpose processor, we have seen that the ALU is the general ALU, whereas in the application specific processors, the ALU part is the custom ALU, which is specialized for that particular application. Now, if we see the benefits and drawback of application specific processors, then benefits are there that it has some flexibility present in them as compared to the single purpose processor, because single purpose they are executing only one single program, but here it is going to perform the program, different types of program, but related to that class of application only. Okay, so some type flexibility is there, also they provide good performance, and size and power consumption is also less. The size is being reduced, the power consumption is less, because if number of components present is less, then power consumption will automatically will be less. Then drawbacks, it is also having high NRE cost. Now, if we see the example of the application specific processor, then its most common example is the microcontroller. Also, the digital signal processors, they are also a type of application specific processors. Microcontroller, because they perform only a specific task, that is why they come under this category. Also these digital signal processor, because they are used in the signal processing applications, like wherever we involve the video and the audio transmission and the signal processing like filtering and modulation is involved. For that we can use the digital signal processors. So because it is belonging to a particular class of application, that is why they are called the application specific processors. So that is all under the processor technology. Now the next technology in the embedded system is the IC technology, also called the integrated circuit technology. So before starting with this technology, let us understand the meaning of the word integrated circuit. Integrated circuit means that we know that whenever we develop any circuit, then that circuit involves many components like gates, logic gates are involved in them, transistors are involved, and wires are involved in it, and including all these components, a circuit is being formed. So integrated circuit means that all the components of the circuit, they are present on a single chip. Okay. So if it is the single chip, that on that chip we are having logic gates also, transistors also, semiconductors are present, wires are present on them. So all the components are being fabricated on that one single chip. Okay, so if that type of circuit is present, then that is called the integrated circuit or called an IC. Okay, so we can say that it is related with the internal circuitry of the embedded systems. We know that embedded systems are also present in the form of the ICs. So IC technology includes the manner in which the digital. The manner in which a digital implementation is mapped onto an IC, because in the circuit we will have the digital components, IC, the logic gates and the transistors, all these are the digital components. So digital implementation of the circuit of the embedded system, how it is made, how all these components are being fabricated on this chip, how they are present, in which how which technology is being used to develop these IC. So that comes under the integrated circuit technology. Now these IC technologies, they differ in their customization toward design, like what application we are using the embedded system, what components will be required for that. So according to that components, the technology which is used to develop the IC for that is being used. So IC technologies, they differ in their customization. Means that in the ICs there are various layers. Okay, so how which component is being used to make each layer of the IC, that comes under the IC technologies. Now there are different types of IC technologies used. Now these IC technology, as I've said, that they differ in their customization to a design. So which component is being used to make the each layer of the ICs, on that also the technologies are based on it. Now in an IC, because we know that it is an integrated circuit, so on that chip the components are present. So according to the number of components present on that single chip, there are different integrated technologies. Like if suppose only 10 components are present, then that is called the small scale integration. So approximately 10 components like 10 transistors will be present on the chip. Then if more than 10 components are present, less than 100, then that is called the large scale integration. If more than 100 components are present, then that is called the very large scale integration. Like 1000 components are present. If more than 1000 components are present, then that is called the ultra large scale integration. So in this way, depending upon that how many components are present on a single chip, there are different integration technologies. Now the integrated circuit technologies in the embedded system, they are of three types. First is full custom, also called VLSI, very large scale integration. Second one is semi-custom. In that we are having gate array and standard cell. And third one is the programmable logic devices. So these technologies, they differ from each other in the way that how the IC is being manufactured, how it is designed, and how the components are present in it, what function the each layer of the IC is being performing. So depending upon them, we are classifying the technologies. Now let us start with the full custom, also called the VLSI, that is very large scale integration. Now in this full custom and VLSI, all the layers which are present in the IC, they are being customized for the digital implementation of the embedded system. Means every layer is being assigned the function for which the embedded system is being tasked. So that is why it is called full custom, because all the layers, their functions is being already decided, components are being present in each of the layers. Okay, so all layers are optimized. Digital implementation. So in the full custom technology, all the layers, the components which have to be present on each layer, what function the components are to be performed, everything is being already done. Okay. So when we have designed this embedded system IC using the full custom technology, then first you have to place and orient the transistors. Placement is being done. Then after this placement, you have to connect the transistors. And then the circuit will be implemented. Now the benefits of this is that they gives us excellent performance. Their size is very small. Sizes is small because less number of components are being used in it. Okay, and because sizes are small, so power consumption is also low. Okay, so that is the full custom or the VLSI technology. Now the drawbacks of this is the high NRE cost and long time to market. So they are being used because in full custom, the layers are being already decided. You have already placed all the components. Okay. So, and function of each component is being already decided. Everything according to the application for which the embedded system is used. For according to that, the components are being already chosen and placed on the IC. Okay. Now, next type of technology is the semi-custom. Now, as I said that in the integrated circuit, there are various layers present, and on each of the layer, the various digital components are present, logic gates, transistors, they are present. On the upper layer, we have the connections, the wires are being connected. Okay, so in the semi-custom, the lower layers, they are either partially or fully built. Okay, now in full custom, everything is being done at the time of manufacturing. Everything is being done by the designer. There is no need to be done by the user. Okay, but in semi custom, because only the lower layers, they are either fully or partially developed, so the designers, they are left with routing of wires, that from where the wires are to be connected, and maybe placing some of the blocks. So there may be possible that some blocks are to be connected, or some connections, or the how the wires are to be connected, that is left. Okay, so this is semi custom. Half work is being already done, half work you have to done when you are using that system. Now benefits of semi custom technology is that these ICs, they give good performance, size is less NRE cost. Okay, but its drawback is that it still requires some time to develop. It still requires weeks to months to develop. Okay, so full custom, everything is being done. Semi custom, half part is being done at the time of manufacturing. Now last type of IC technology is the programmable logic devices, that is PLD. Now in this programmable logic device, this type of technology, there are also three parts called the programmable logic array, programmable array logic, and programmable gate array. PLA, PAL, and PGA. PLA, programmable logic array, programmable array logic, and programmable gate array. Okay. Now in this type of technology, all the layers, they already exist. Okay, all the layers are already present in the IC. Just the designer has to purchase that IC and make the appropriate connections with the help of the wires. So designers, they can purchase the IC according to the application for which they have to use the embedded system. They can either create some new connections, or they can destroy some of the old connections. Okay, so connections can be created or destroyed according to the implementation, and all the layers are already present in this type of IC. Now the benefits are very low NRE cost, which we have seen that it was the drawback in the earlier technologies. This has become an advantage in the programmable logic devices, that it has very low NRE cost and great time to market. Means very less time is taken to develop these types of ICs. But the drawback is that they are having very high unit cost. If the volume is more, means the number of components present is more, and in that case the cost per unit of the components, that is very high. Also, power consumption is more because more number of components are present. Also, they are slower as compared to other ICs. Okay, so that was the IC technology, integrated circuit technology. We have seen that it is of three types: full custom, semi-custom, and the programmable logic devices. Okay, now the third type of technology present in the embedded system is the design technology. Now, whenever we are using any embedded system, then first we have to design the embedded system. So, design technology means that the methods which are used to manufacture the system, that is the design technology. So, design technology involves a procedure. Okay, because whenever we are developing the embedded system, we have some specifications, we have some limits, and some rules are there that according to these specification you have to develop the embedded system. There are some cases that they involve some complex procedures are involved in it. So large specifications, short time to market. Okay, these are some of the design challenges. Design challenges means that when we are designing the system, then we have to meet all these rules. Okay, that there are various specifications of the embedded system. We also require that the embedded system should be developed in a very short time, high performance will be given by it, and multiple designers. Okay, so these are the design challenges. So if we have used a proper design methodology, proper design methods are being used, then it becomes very easy to improve the quality, to improve the performance of the embedded system. So proper design methodology helps to manage the design process and improves the quality and performance. So for all these purpose, we require to get an information about the design technology of the embedded system. Okay. Now there is also another term in this which is called the design flow. What is design flow? When we are designing the embedded system, then what is the sequence of the steps which is to be followed? That is called the design flow. Okay, that how we are designing the system. Now these design steps, they can be fully automatic or partially automated. Okay, now to do the designing of the embedded system, we have various design tools. Okay, nowadays, due to the development of the technology, there are various design tools available. Like we are having software engineering tools, compilers, and computer aided design tools. Okay, so for the designing, we can have these various types of tools can be used. Now, this design technology, it is also consist of three things. First is compilation and synthesis. Then libraries and IP. And third is test and. So in the compilation and synthesis means that how we have to develop the embedded system. We are going to make a procedure for it. Okay, we will write the steps that how we are going to do the designing. Okay, so in compilation and synthesis, it involves the automates the exploration, and insertion of implementation. How we are going to implement the circuit, how we are going to design it. So at this level, we are going to make design procedure. We will write the procedure, we will write the steps, that in this way we will do the designing. So it is the compilation part. Then in libraries and IP, if suppose that we want to use some, in the libraries all the books are being kept, so in just a way, in the libraries of the embedded system, the systems which are being already developed, they can be used. Some, like some if method we want to use in it. Okay, so this is used for a reference purpose. Okay, so in this, it incorporates pre-designed implementation. Okay, so already which are designed earlier, it is going to use those implementations or the digital implementations into the system. Okay, now test and verification, here we have to verify that whether the design which we have developed, it is giving us the accurate results or not. It can withstand all the possibilities, all the corrections it has done. Okay, so in test and verification, we are going to verify that whether the embedded system is giving us the accurate results or not. So it means it ensures correct functionality of the system. So these are the steps which are involved in the design technology. Okay. Now, if we, as I've said, that design flow is the sequence of steps to be followed in the design method. So here, first of all, the system specifications are being given. Like what function the system has to be performed, what are the things which are being mandatory in the system. So system specifications are done. Then behavioral specification. After that, you have to tell the register transfer specification, called the RT specifications. Like embedded system, we will include the transistors and the registers. So what specifications are for them, then that you have to specify. After that, which logic you are being using, so logic specification is there. So after the system specification, the model is called the HLL model. After this, it is called the behavioral model. Then here it is called the RT model. And in last, it is called the logic model. And when all this is being developed, then in the last, it is being sent for the final implementation. Okay. So this is the design sequence. Okay. So this completes the design technology. So here in this video, we studied the different technologies in the embedded system. There are three key technologies: processor, integrated circuit technology, and the design technology. We saw the different technologies in these category. Like in processor, we saw that there are three types of processor: general purpose, single purpose, and application specific. In the IC technology, we saw that there are three types of technologies: full custom, semi-custom, and programmable logic devices. In design technology, we also saw the three types: the compilation synthesis, the libraries, and the test and verification. So I hope that this topic is now clear to you. Thank you.